Welcome to another session of moving charges and magnetism part 2. Moving charges and magnetism part 2. So here, uh, the second part of the moving charges and magnetism is that the last class we have discussed the Biot-Savart's law. That's mu naught by 4 pi I dl sine theta divided by r square. This is where we are. For theta is equal to 0, that's along the conductor. Okay, along the conductor. So theta equal to 0 means it's along the conductor. So you get the value of B as 0. So which means the magnetic field on the conductor is 0. So that's the first inference you can have. You can make a note of this one. So the next part is that if the theta is equal to 90 degrees, you have the value of B happens to be mu naught by 4 pi IDL divided by R square. That's maximum value for you. Maximum. So we have to write dV over here, dV, and then that's the maximum value what you are going to get. So this is the very basic fundamental stuff. And for theta equal to 180 also, for theta is equal to 180 degrees, the value of dB is 0, which is the minimum. So here are the three conditions what you can have using moving charges and magnetism. That's part 2. Uh, Next is one important calculation. What we have to do is that here, suppose I'll clear this off. Uh, so what's the value of, it's like a question. So what's the value of 1 by mu naught epsilon naught? So actually, surprisingly, it gives the value of c square. Okay, velocity of light whole square. So we'll see why it is so. So we know the value of mu naught is 4 pi into 10 to the power of minus 7 Tesla meter per ampere, and then we already know that 1 by 4 pi epsilon naught. This value is 9 into 10 power 9. So this is 9 into 10 power 9 Newton meter square coulomb power minus 2. So when we take the values into consideration, and then we got to multiply these things. Okay, so you have what I do is I'll consider the value of 1 by mu naught times epsilon naught and multiply and divide with 4 pi once. So I have 4 pi by mu naught. I'll take it as one factor, and 1 by 4 pi epsilon naught as the other factor. So that's the first one gives me 1 by 10 to the power of minus 7, and the second one is 9 into 10 to the power of 9. So this works out to be 9 into 10 to the power of 16 meter square second power minus 2. When you work out the units, you will get this. So which is nothing but velocity of light whole square. Velocity of light is 3 into 10 to the power of 8 meters second inverse whole square. So that's the answer for this one. So uh, You can make a note of this. This is a important question what you can see. And the direction of the magnetic field. The next part is the direction of magnetic field. Direction of magnetic field. That's the next part. And how do we see the direction of the magnetic field? So suppose this is a conductor like this. Place your thumb in the direction of motion of the current. Okay, and then curl the fingers along the conductor. So these are my fingers. I'm curling my fingers along the conductor like this. Okay, if I curl my fingers along the conductor, if I curl the fingers along my conductor, so these are the fingers, these are my fingers. I have curled my fingers along the conductor, and this is my hand. Okay, so I hold the conductor like this. So this is my conductor. I hold the conductor like this. A current is flowing through this conductor like this. Okay, I hold the conductor like this and place the thumb in the direction of the current flow. The curl of my fingers shows the direction of the magnetic field. The curl of my fingers shows the direction of, so this is my palm. Curl of the finger shows the direction of magnetic field. So this is the end of the second part of the video. So we meet in the next video with another further topic. Yeah, thank you.